Opal is a hydrated amorphous form of silica. Its water content may range from 3% to 21% by weight, but is usually between 6% and 10%. Because of its amorphous character, it is classed as a mineraloid, unlike the other crystalline forms of silica which are classed as minerals. It is deposited at a relatively low temperature and may occur in the fissures of almost any kind of rock, being most commonly found with limonite, sandstone, rhyolite, marl and basalt. Opal is the national gemstone of Australia, which produces 97% of the world's supply. This includes the production of the state of South Australia, which accounts for approximately 80% of the world's supply. The internal structure of precious opal makes it diffract. Depending on the conditions in which it formed, it can take on many colors. Precious opal ranges from clear through white, gray, red, orange, yellow, green, blue, magenta, rose, pink, slate, olive, brown, and black. Of these hues, the reds against black are the most rare, whereas white and greens are the most common. It varies in optical density from opaque to semi-transparent. Common opal, called poch by miners, does not show the display of color exhibited in precious opal. Precious opal. Precious opal shows a variable interplay of internal colors, and even though it is a mineraloid, it has an internal structure. At micro scales, precious opal is composed of silica spheres some 150 to 300 nanometers in diameter in a hexagonal or cubic close-packed lattice. These ordered silica spheres produce the internal colors by causing the interference and diffraction of light passing through the microstructure of the opal. It is the regularity of the sizes and the packing of these spheres that determines the quality of precious opal. Where the distance between the regularly packed planes of spheres is approximately half the wavelength of a component of visible light, the light of that wavelength may be subject to diffraction from the grating created by the stacked planes. The spacing between the planes and the orientation of planes with respect to the incident light determines the colors observed. The process can be described by Bragg's law of diffraction. Visible light of diffracted wavelengths cannot pass through large thicknesses of the opal. This is the basis of the optical band gap in a photonic crystal, of which opal is the best-known natural example. In addition, microfractures may be filled with secondary silica and form thin lamellae inside the opal during solidification. The term opalescence is commonly and erroneously used to describe this unique and beautiful phenomenon, which is correctly termed play of color. Contrarily, opalescence is correctly applied to the milky, turbid appearance of common or poch opal. Poch does not show a play of color. For gemstone use, most opal is cut and polished to form a cabochon. Solid opal refers to polished stones consisting wholly of precious opal. Opals too thin to produce a solid, may be combined with other materials to form attractive gems. An opal doublet consists of a relatively thin layer of precious opal, backed by a layer of dark-colored material, most commonly ironstone, dark or black common opal, onyx or obsidian. The darker backing emphasizes the play of color, and results in a more attractive display than a lighter poch. An opal triplet is similar to a doublet, but has a third layer, a domed cap of clear quartz or plastic on the top. The cap takes a high polish and acts as a protective layer for the opal. The top layer also acts as a magnifier, to emphasize the play of color of the opal beneath, which is often of lower quality. Triplet opals therefore have a more artificial appearance, and are not classed as precious opal. Combined with modern techniques of polishing, doublet opal produces similar effect of black or bolder opals at a mere fraction of the price. Doublet opal also has the added benefit of having genuine opal as the top visible and touchable layer, unlike triplet opals. Common opal. Besides the gemstone varieties that show a play of color, there are other kinds of common opal such as the milk opal, milky bluish to greenish. Resin opal, which is honey yellow with a resinous luster. Wood opal, which is caused by the replacement of the organic material in wood with opal. Mineralite, which is brown or gray. Rhyolite, a colorless glass-clear opal sometimes called muller's glass. Geyserite, also called silicious sinter, deposited around hot springs or geysers. And diatomite or diatomaceous earth, the accumulations of diatom shells or tests. Other varieties of opal. Fire opal is a transparent to translucent opal, with warm body colors of yellow, orange, orange-yellow or red. It does not usually show any play of color, although occasionally a stone will exhibit bright green flashes. The most famous source of fire opals is the state of Querétaro in Mexico. These opals are commonly called Mexican fire opals. Fire opals that do not show play of color are sometimes referred to as jelly opals. Mexican opals are sometimes cut in their rhyolitic host material if it is hard enough to allow cutting and polishing. This type of Mexican opal is referred to as a cantor opal. There is also a type of opal from Mexico referred to as Mexican water opal, which is a colorless opal which exhibits either a bluish or golden internal sheen. Girasol opal is a term sometimes mistakenly and improperly used to refer to fire opals as well as a type of transparent to semi-transparent type milky quartz from Madagascar which displays an asterism, or star effect, when cut properly. However, there is a true girasol opal that is a type of halite opal, that exhibits a bluish glow or sheen that follows the light source around. It is not a play of color as seen in precious opal but rather an effect from microscopic inclusions. It is also sometimes referred to as water opal as well when it is from Mexico. The two most notable locations of this type of opal are Oregon and Mexico. Peruvian opal is a semi-opaque to opaque blue-green stone found in Peru which is often cut to include the matrix in the more opaque stones. It does not display pletroism. Blue opal also comes from Oregon in the Hawaii region as well as from Nevada around Virgin Valley. Sources of opal. Australia produces around 97% of the world's opal. 90% is called light opal or white and crystal opal. White makes up 60% of the opal productions but cannot be found in all of the opal fields. Crystal opal or pure hydrated silica makes up 30% of the opal produced, 8% is black and only 2% is boulder opal. The town of Coobapedy in South Australia is a major source of opal. The world's largest and most valuable gem opal Olympic Australis was found in August 1956 at the 8 Mile opal field in Coobapedy. It weighs 17,000 carats and is 11 inches long, with a height of 4A3 of 4 inches and a width of 4A1 or 2 inches. The Minturpee opal field located approximately 250 km northwest of Coobapedy has also produced large quantities of crystal opal and also the rarer black opal. Over the years it has been sold overseas incorrectly as Coobapedy opal. The black opal is said to be some of the best examples found in Australia. Andamooka in South Australia is also a major producer of matrix opal, crystal opal, and black opal. Another Australian town, Lightning Ridge in New South Wales, is the main source of black opal, opal containing a predominantly dark background. Boulder opal consists of concretions and fracture fillings in a dark silica sandstone matrix. It is found sporadically in western Queensland, from Kynuna in the north, to Yawarr and Koroit in the south. Its largest quantities are found around Junda and Quilpie in southwest Queensland. Australia also has opalized fossil remains, including dinosaur bones in New South Wales, and marine creatures in South Australia. The rarest type of Australian opal is pipe opal, closely related to boulder opal, which forms in sandstone with some iron oxide content, usually as fossilized tree roots. The Virgin Valley opal fields of Humboldt County in northern Nevada produce a wide variety of precious black, crystal, white, fire, and lemon opal. The black fire opal is the official gemstone of Nevada. Most of the precious opal is partial wood replacement. The precious opal is hosted and found within a subsurface horizon or zone of bentonite in place which is considered a low deposit. Opals which have weathered out of the in-place deposits are alluvial and considered placer deposits. Miocene age opalized teeth, bones, fish, and a snakehead have been found. Some of the opal has high water content and may desiccate and crack when dried. The largest producing mines of Virgin Valley have been the famous Rainbow Ridge, Royal Peacock, Bonanza, Opal Queen, and W.A.T. Stone Tree Black Beauty mines. The largest unpolished black opal in the Smithsonian Institution, known as the Rubeling Opal, came out of the tunneled portion of the Rainbow Ridge mine in 1917, and weighs 2,585 carats. The largest polished black opal in the Smithsonian Institution comes from the Royal Peacock Opal mine in the Virgin Valley, weighing 160 carats, known as the Black Peacock. Another source of white base opal or creamy opal in the United States is Spencer, Idaho. A high percentage of the opal found there occurs in thin layers. Other significant deposits of precious opal around the world can be found in the Czech Republic, Slovakia, Hungary, Turkey, Indonesia, Brazil, Honduras, Guatemala, Nicaragua and Ethiopia. In late 2008, NASA announced that it had discovered opal deposits on Mars. Synthetic opal, as well as occurring naturally, opals of all varieties have been synthesized experimentally and commercially. The discovery of the ordered sphere structure of precious opal led to its synthesis by Pierre Gilson in 1974. The resulting material is distinguishable from natural opal by its regularity. Under magnification, the patches of color are seen to be arranged in a lizard skin, or chicken wire pattern. Furthermore, synthetic opals do not fluoresce under UV light. Synthetics are also generally lower in density and are often highly porous. Two notable producers of synthetic opal are the companies Kyocera and Inamori of Japan. Most so-called synthetics, however, are more correctly termed imitation opal, as they contain substances not found in natural opal. The imitation opals seen in vintage jewelry are often foiled glass, glass-based slocum stone, or later plastic materials. Other research in microporous structures have yielded highly ordered materials that have similar optical properties to opals and have been used in cosmetics. Local atomic structure of opals, the lattice of spheres of opal that cause the interference with light are several hundred times larger than the fundamental structure of crystalline silica. As a mineraloid, there is no unit cell that describes the structure of opal. Nevertheless, opals can be roughly divided into those that show no signs of crystalline order and those that show signs of the beginning of crystalline order, commonly termed cryptocrystalline or microcrystalline opal. Dehydration experiments and infrared spectroscopy have shown that most of the H2O in the formula of CO2 and H2O of opals is present in the familiar form of clusters of molecular water. Isolated water molecules, and silanols, structures such as COH, generally form a lesser proportion of the total and can reside near the surface or in defects inside the opal. The structure of low-pressure polymorphs of anhydrous silica consist of frameworks of fully corner-bonded tetrahedra of CO4. The higher-temperature polymorphs of silica cristobalite and tridymite are frequently the first to crystallize from amorphous anhydrous silica, and the local structures of microcrystalline opals also appear to be closer to that of cristobalite and tridymite than to quartz. The structures of tridymite and cristobalite are closely related and can be described as hexagonal and cubic close-packed layers. It is therefore possible to have intermediate structures in which the layers are not regularly stacked. Microcrystalline opal. Opal CT has been interpreted as consisting of clusters of stacking of cristobalite and tridymite over very short length scales. The spheres of opal in opal CT are themselves made up of tiny microcrystalline blades of cristobalite and tridymite. Opal CT has occasionally been further subdivided in the literature. Water content may be as high as 10 Wt%. Lucitite is a synonym. Opal C, also called lucitine, is interpreted as consisting of localized order of cristobalite with a lot of stacking disorder. Typical water content is about 1.5 Wt%. Non-crystalline opal, two broad categories of non-crystalline opals, sometimes just referred to as Opal A, have been proposed. The first of these is Opal AG, consisting of aggregated spheres of silica, with water filling the space in between. Precious opal and Poch opal are generally varieties of this, the difference being in the regularity of the sizes of the spheres and their packing. The second Opal A is Opal AN, or water-containing amorphous silica glass. Rhyolite is another name for this. Non-crystalline silica in siliceous sediments is reported to gradually transform to Opal CT and then Opal C as a result of diagenesis, due to the increasing overburden pressure in sedimentary rocks, as some of the stacking disorder is removed. Naming: The word opal is adapted from the Roman term opalus, but the origin of this word is a matter of debate. However, most modern references suggest it is adapted from the Sanskrit word opala. References to the gem are made by Pliny the Elder. It is suggested it was adapted from Ops, the wife of Saturn and goddess of fertility. The portion of Saturnalia devoted to Ops was opalia, similar to opalus. Another common claim that the term is adapted from the Greek word, opalios. This word has two meanings, one is related to seeing, and forms the basis of the English words like opaque, the other is other as an alias, and alter. It is claimed that opalus combined these uses, meaning to see a change in color. However, historians have noted that the first appearances of opalios do not occur until after the Romans had taken over the Greek states in 180 BC, and they had previously used the term padiros. However, the argument for the Sanskrit origin is strong. The term first appears in Roman references around 250 BC, at a time when the opal was valued above all other gems. The opals were supplied by traders from the Bosporus, who claimed the gems were being supplied from India. Before this the stone was referred to by a variety of names, but these fell from use after 250 BC. Historical superstitions. In the Middle Ages, opal was considered a stone that could provide great luck because it was believed to possess all the virtues of each gemstone whose color was represented in the color spectrum of the opal. It was also said to confer the power of invisibility if wrapped in a fresh bay leaf and held in the hand. Following the publication of Sir Walter Scott's Anne of Geierstein in 1829, however, opal acquired a less auspicious reputation. In Scott's novel, the Baroness of Arnheim wears an opal talisman with supernatural powers. When a drop of holy water falls on the talisman, the opal turns into a colorless stone and the Baroness dies soon thereafter. Due to the popularity of Scott's novel, people began to associate opals with bad luck and death. Within a year of the publishing of Scott's novel in April 1829, the sale of opals in Europe dropped by 50%, and remained low for the next 20 years or so. Even as recently as the beginning of the 20th century, it was believed that when a Russian saw an opal among other goods offered for sale, he or she should not buy anything more since the opal was believed to embody the evil eye. Opal is considered the birthstone for people born in October or under the sign of Scorpio and Libra. Famous opals: the Olympic Australis, the world's largest and most valuable gem opal; the Andamooka Opal, presented to Queen Elizabeth II, also known as the Queen's Opal; the Plesiosaur from Andamooka, the finest known opalized skeleton on Earth; the Burning of Troy, the now lost opal presented to Joseph copyright finder Bihanas by Napoleon I of France; and the first named opal, the Flame Queen Opal, the Halley's Comet Opal, the world's largest uncut black opal. Although the clock faces above the information stand in Grand Central Terminal, Manhattan, New York, are often said to be opal, they are in fact opalescent glass. The Rubeling Opal, Smithsonian Institution; the Galaxy Opal, listed as the world's largest polished opal in the 1992 Guinness Book of Records. See also, Opalite, optical phenomena, references. External links, Farlang Opal Hist. References. Localities, anecdotes by Theophrastus, Isaac Newton, Georg Agricola etc. ICA's Opal page, International Coloured Stone Association, South Australian Museum. The Opal fossils of South Australia accessed December 2, 2011.